The plenary the plenary session is about to begin in next 2 minutes. Let me prepare something.
Dari 19 negara. Iya. TTS.
Okay, good morning, ladies and gentlemen. Our honorable guest, Bapak Hanafi, the chairman of Institut Teknologi Tangerang Selatan, Jakarta, Bapak Ono Widodo Purbo, and all participants, all authors, and their students of ITTS. It's a great honor to welcome every one of you at the ICAICST, the International Conference on Artificial Intelligence and Computer Science Technology 2021. Organized by Institut Teknologi Tangerang Selatan, Indonesia, supported by IEEE Indonesia section. We have 52 accepted and to be presented papers today out of 89 papers coming from 19 countries. And we have just finished the first session this morning before this plenary session. Ladies and gentlemen, our first agenda in this plenary session is listening to an opening speech by the chairman of ITTS, Mr. Hanafi. Before enjoying the opening speech, allow me to share his profile. Mr. Hanafi graduated from his PhD program from University Technical Malaysia, Malacca with a thesis entitled Recommended System using Deep Learning and Matrix Factorization. Currently, he is the chairman of Institut Teknologi Tangerang Selatan, Indonesia, after going through a life as a lecturer at Amikum University for about 10 years. Ladies and gentlemen, without delaying any further, let's welcome Mr. Hanafi. Pak Hanafi, the floor is yours. Pak Hanafi?
Mr. Hanafi, already yet?
Pak, aku banyak orang ini.
Hanafi, where are you, Pak Hanafi? Alif, can you find me Pak Hanafi, please?
Wait.
Okay, there you go. Okay. Silakan Pak Hanafi.
Mr. Hanafi, time is yours.
Okay. Okay, let me share my document. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. According to Indonesian Western time, in this conference, let me thank and grateful. The first was the IEEE Indonesian section, who has always support and guiding us to this conference, so this conference can be held successfully. And the second, for all of committee members who has helped work with high commitment and best effort, especially Prof. Ferry, Dr. Yuni, Dr. Vijay, Dr. Agung, and team, and so on. The third, ITTS, Institut Teknologi Tangerang Selatan, as a host of this conference, that support us totally. The fourth is all the active participants from expert, academic, and industry. And the last is for my expert, my lecturer, for the legend, Prof. Ono and Prof. Burhan. He is my lecturer in UTEN. For the second, let me introduce just a little bit of Institut Teknologi Tangerang Selatan. ITTS is very young school of computing located near of capital city of Indonesia, Jakarta. There are 3 subject field of focus study, including information system, informatics, and computer system. Next slide. Recently, we have considered the collaboration with industry partner such as Linksys, Datalink, Cisco, Android, and Aruba, and so on. Also, government partner such as Kominfo Tangerang Selatan, Kementerian Perhubungan, Ministry of Transportation, and Kementerian Pariwisata and Industri Kreatif, and so on. ITTS also considered to join with a company from another country, such as Cyberport Malaysia. We have conducted to join development in research, especially on a government project and fintech technology. I am to sharing knowledge, experiment in research, collaborative in learning process, student exchange, and scholarship. We have signed meeting of understanding with Universitas Amikom Yogyakarta, Amikom Purwokerto, UPI Bandung, and collaboration in fast track master program with UTM Malaysia. Also, MTA master program from Amikom Yogyakarta. As we know, Amikom is the leading technology in animation application. Their product provide all around the world, include Hollywood and Disney. Our conference decided to put the topic in artificial intelligence and computer science. As we know, AI has been influenced in our living paradigm. The transformation of AI become deep learning model proven better performance over previous technology. Deep learning also outperformed in computer science territory, including natural language processing, voice recognition, image processing, text processing, and so on. However, AI, a new era, is still facing the challenges for example, in text processing. Deep learning is facing in generating in contextual also. There's the shortcoming in this territory. Also, the compatibility and performance in various language model. And there are many challenges in another research and industry field. However, we must optimistic where many problems will be achieved better performance immediately, and will resist some innovation in this conference. Just to inform you, the total number of participants that submitted in this conference achieved 100 paper, and only 49 paper that approved by reviewer. Congratulations to all participants that reached tremendous finding in your innovation and research. Don't be give up to the researcher that your paper was rejected. There are many opportunities on the next section. Finally, we hope this conference raise some solution for the previous problem. To reach the solving for the problem for society, human being, and our living quality. Also, to solve the problem in industry issue. Finally, we hope all of you enjoy to sharing, discuss, learning in this conference. This is the last presentation, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Bapak Hanafi, for the wonderful presentation. Yeah, next we're going to listen together to Bapak Ono Widodo Purbo presentation. But let me share something about Bapak Ono Widodo. Bapak Ono Widodo Purbo, born in Bandung in 1962. He's a public figure and well recognized as an expert on information technology. Mr. Ono was graduated from ITB, Bandung, Institut of Technology, Bandung, with a major of electrical engineering. Then he continued his study to McMaster University and Waterloo University, Canada. Furthermore, Mr. Ono Widodo Purbo is also well known for his work as an author of more than 40 books, educators, and also speakers at many events. As an activist, Mr. Ono is also recognized for his work introducing Wajan Bolik as the smallest district internet connection. Without any further ado, let's welcome Mr. Ono Widodo Purbo. Bapak Ono, the floor is yours.
Thank you very much. Good morning, everyone. Sorry, the light in this room is not very good, so my face maybe is too dark. I will share my slide. Okay. So thank you very much for the opportunity. Thank you, Pak Hanafi. Thank you, Pak Agung. Thank you for all the organizer. So thank you, everyone, for coming. I will talk about improvisation on low-cost internet technology. Okay, this is like 30 years of effort, 30 years of experience trying to improve, trying to motivate people how to build a low-cost internet technology. Okay, I have uploaded my slide in the chat, so you can freely download my slide. My slide have lots of URLs, lots of link to the Google and so on. So so my type of presentation may be a little bit different than the normal people. So the outlines. So I will talk about the objective, why we do such approach in the technology. And then the story began about 30 years ago 30 years ago, early attempts in building low-cost internet technology. We use walkie-talkie. We use packet radio technology, which connected to a walkie-talkie, and then gradually we modify Wi-Fi to long-range connection. Long range means what? 50 to 150 kilometers connections. And then we also introduce a community network. Sometimes people call it a neighborhood network to reduce the internet costs. And then later, this is more recent, we try to introduce open source based transceiver station, which is 2G, 3G, 4G, 5G technology to the community, and community start building community cellular in their village. And also during this period, during the pandemic period, during coronavirus period, we try to introduce internet offline technology. So internet is not an online, this is internet offline technology. So hopefully people can get their knowledge offline, not online, because online is too expensive for many people in the village. And then the last, I try to share how to empower the community, how to educate them, how to make them knowledgeable to adopt the technology. Okay. So the research objective is low cost actually. Many of us, when we do research, we are trying to increase the quality, make it a much better technology. In my case, it's different. So I'm not really pushing for increasing the performance. I'm more leaning towards lowering the quality, but still usable. So basically lowering the quality, it means lowering the cost. And then the most challenging one is how to spread the knowledge, how to spread the technology, convincing the society, educating the society, and then hoping when the society convinced, they will invest, deploy, and operate the technology themselves. So basically a self-finance process. So people invest their own money, they deploy their own technology, and they operate the technology. To be honest, this is not an easy process, and what you are going to see in this talk, this is a 30 years endeavor, 30 years of struggle, 30 years of fighting, basically. Well, I'm not talking about the fighting in this talk, but in reality, we actually do a lot of fights. Okay, so this is a 3 years process. 30 is very long time process, but it's fun. Okay, let me show you some of the results. This is some of the results. The keyword you can search in Google. The keyword is wajan bolik or RT RW net. What is wajan bolik? We go to Google. We know wok for cooking. Okay. Oh, I hope my Google is working fine. Wow. Okay. This is wok for cooking. You know, for cooking wok. Okay. And in Indonesian word, wok, it's not wok. It's wajan. This is the Indonesian word for wok. Same pictures. This is wok in English. This is wajan in Indonesian words. Okay. And then we use this as an antenna, as a parabolic antenna. Let me show you a parabolic antenna. What is parabolic antenna? So the innovation is very parabolic antenna. The innovation is very simple, basically. So we know the parabolic antenna is like this. It's very similar to wok. It's very similar to wajan. The problem with wajan and wok, the efficiency, the precision is not that precise. It's about 60% precise. But still, in the wok, the focus point, the focal point is around this range, but it's not in one single point. That's the problem with wok for cooking. while in parabolic antenna, the focus point is in single point like this. So it's very precise. They create this surface precisely, so all the signal will be reflected to single point. While in walk, the signal is not reflected into a single point, but still workable. So what we do is we combine parabolic antenna and wajan. So, oops, sorry. So we combine these two into wajan bolik. That's it. That's the innovation. So this is what we, okay, this is the results. We combine walk and parabolic antenna into single walk. But the interesting thing is we use Google here. So we use Google, use wajan bolik as keyword, and you check the websites. All of these websites are Indonesian websites. Surprise, surprise. So a technology can be spread to many people, and people will adopt the technology and they build the technology for their own purpose. So this is some people actually trying to use tin can antenna, which is the this part of the walk for connection. So this is what we do. This is a fun process when we spreading the technology. And having this kind of technology, they can make a longer distance connections for the internet. Okay, so this is one walk bolik. Okay, the other one we need to make a neighborhood, basically a tethering. This one, the RT/RW net is basically internet tethering. So we can tether the internet to our surroundings, but the surroundings is our neighborhood, the whole neighborhood, like 10 houses or 20 houses, and share the cost among the houses. So make the internet low cost, lowering the cost for the internet. Okay, this is the example of RT/RW, similar to walk bolik. Okay, if you look at the URL, all of the URL are Indonesian URL. Surprise, surprise. This is our Indonesian URL, mostly Indonesian URLs, mostly Indonesian sites. The fun stuff is we can go to online shop. For example, one of the online shop is Bukalapak in Indonesia. Okay, let me check for walk bolik. Wajan bolik. Okay, people sell the equipment. 75,000 rupiah, which is like $7, $5, $20. $20 is included in $20 is normally USB Wi-Fi. This is include USB Wi-Fi here and the cable and so on. So this is $30 include the USB Wi-Fi. Very simple setup. So people selling this, okay, selling the technology. The technology we introduce, we invent, people actually adopting the technology and they use it. Let me change the keyword into RT/RW net. Same thing. Surprise, surprise. People sell these things. Okay, they make money from the invention. This is the important part. This is the important thing. The technology is actually adopted by the people. People believe, people convince, they believe in the technology, and they invest, they deploy, they operate the technology. That's the beauty of it. Because of this, a lot of people in Indonesia can have low-cost internet access. Okay, so this is the RT/RW net. It's people sell these things. So don't ask, please don't ask how much money do I get. I get I get a lot of money from God, so don't worry about that. Okay, so this is the example of the final result. Now I like to show you the process. Okay, so this is the objective, lowering the cost, spreading the technology, and this is 30 years process, and this is the final results now. In early days, in the early attempts, this is like 30 years ago, like I'm still around 20, 25 years old, very, very young. Okay, you can check these websites. Okay, these two URLs. Okay, let me see. I think I already opened this one. Okay, I think I can translate okay into English. Can I read? Okay. So this is Indonesian Internet History website. You can check the Internet History website. You can check the pre-internet history, including the beginning of the internet, Indonesian internet in 1990s. When you see the beginning of the internet, early internets. Okay, let me see. Feel free to put questions in the chat. I will try to read the question in the chat box. Okay, when you see the early internet, we use this kind of equipment. Okay, this is the equipment, the first internet gateway at Institute of Technology in Bandung. Institute of Technology in Bandung is the like the oldest Institute of Technology in Indonesia. Okay, this is the first internet gateway. Okay, let me see. Let me show you the important things. The important feature of the gateway. First, the diskettes. See, still big diskettes. They don't. This gateway, it didn't use lease line. It didn't use fiber optics. Used radio. This radio is used for people talk to each other, and we don't modify the radio. We actually injecting data into this radio. Okay, then we create the network that way. Okay, this is our server. At that time, this is our network actually in 1994. Mind you, these are radio network. It doesn't involve phone network. Yes, it involves some satellite network. This one, Vitasat, Oscar, and ETS-5 satellite. So it uses 5 satellite. This ETS-5 is Japan satellite. Vitasat is US. Oscar is amateur radio satellite. Mostly US, Europe. Okay. So yes, we use those things, but all these links is radio network. The speed is 1.2 kilobit per second. It's fun, eh? Okay, very fun. Okay, now having this radio network, if you like to see the actual radio technology, you can Googling using the keyword ITB packet radio. Let me show you how it looks like. Sorry, I have to. Sorry. Okay, let me share again. Share screen. Okay. Okay. I use ITB packet radio keyword. Show you the result. So this is the technology, and you can see more detail of the technology, like the design of the modem, and this is some of our more better setup. This one is single sideband radio, so it can go for long distances. Okay, and this one is our how can I tell? This is our early Wi-Fi long-range network, but this one is not using the current Wi-Fi frequencies. So this is our 1 megabit per second link. We use loop IAGI, and the frequency is 900 megahertz, which is GSM frequency. That's why the operator a little bit upset with me, because I am stealing their frequency. And then the ministry talked to me, and I nearly go to jail because of this. But this is part of our experiment. Then we negotiate. We move to 2.4 gigahertz. So that's why we moved to 2.4, and then we struggle to liberate 2.4. Finally, in 5 January 2005, 2.4 gigahertz, our Wi-Fi frequency now is free. It's because of, in early days, we actually stealing the frequency like this. Okay, so we use this kind of technology. Now, so this is the 900 megahertz experiment. This is a little bit illegal, but well, it's part of the process. Sorry. Okay, so you can see the early attempts. we go from 1.2 kilobit per second into 1 to 2 megabit per second. The 2 megabits per second still illegal, and we gradually move into 2.4 gigahertz, which is the one we use now. Okay, and then okay, wajan bolik, we have seen wajan bolik. Some people actually use satellite, the actual satellite parabola, rather than wajan. Rather than walk, we use satellite parabola, and we can go further. Okay, I'll show you what we did now today. Okay, I will show you using, this is what we did now. This is today. This is not 20 years ago. This website, linkui.com, it belongs to Ubiquiti. Okay, I will show you what kind of link we are dealing with. Okay, I will go to Manado. Manado is the northest city in Sulawesi Island. Okay, let me. Okay, so this is Sulawesi Island. Sulawesi Island. This is Manado. Okay, okay. I have to grab of the URLs. Okay, sorry. I need the, so not URL, I need the coordinate. What's here? Okay, I need this one. So I get the coordinate, an approximate coordinate of the Manado. I'll show you what kind of capability we can do using this kind of connection. Okay, so this is in Manado area. Okay, this is Manado area. Some of my friends put a, okay, I add point-to-point link, put point-to-point link here in this mountain here. Okay, this mountain approximately, and then what they do, they are trying to make a connection to this island Ternate. From this area to Ternate is, I'll show you the whole picture. So I am here in Jakarta now. Okay, so they make a connection from this city Manado, to Ternate, which is a small island here. Okay, the distance is about 300 kilometers, and this is what how they did it. Okay, show you a little. Okay, see this small island in between, they put a relay here. Okay, see the line becoming red because it goes down into the water. So I have to change the height into this area here. This is how they do it. Okay, see, it's becoming yellow now. So it's an okay connection. It's sorry. Okay, so from this mountain to this island, it's okay now. Okay, and then they make another connection from this island to Ternate. I have an account. Okay, let me see if I can sign in. You can create an account for free. This service is for free from Ubiquiti, and you can okay, you can design your link using this kind of connection. See, now I have two green connection. One is from Manado to the island in between, and then the other one is from the central the middle island here to Ternate. The first leg is 136 kilometer distance, and the speed is 200 megabit per second, and the second leg is 120 kilometers approximately. The speed is about 200 megabit per second. So the speed is quite high. If we want to make a higher speed, this connection is real today. So people actually building this connection. Some of my friends is now experimenting with 11 gigahertz equipment. Okay. Let me see if I can change it. Okay. So the speed can be approximately 800 megabit per second per leg. So if I can increase the bandwidth, I will increase the bandwidth to 56 megahertz. The speed is about 1 gigabit per second from Manado to Ternate. At 1 gigabit per second, the total distance close to 300 kilometers. So we are dealing with this kind of technology today. The early technology we use walk, but today it's totally different. The cost of this equipment is not that expensive, you know. So we play with this kind of technology. We can have low cost, still low cost. Of course, it's much costly than a walk. it's, but still, it's low cost. At 1 gigabit per second, the distance is about 300 kilometers. So we are dealing with this kind of technology. Okay, so now we have long-range Wi-Fi. Okay, now having this long-range Wi-Fi, we need to connect the whole neighborhood. Okay, so as I mentioned before, we do tethering basically to the neighborhood, and you can Google RT/RW-net, and you can buy the equipment in the store. But today, many people actually modifying RT/RW-net. Okay, I'll show you in my note. I normally take a note on what happened. RT/RW-net. Okay. Let me see. You can translate into English if you like, but I like to show you at the end. Okay, this one, this last link. This is the most important, most fun. Actually, people sending me their story on how they build RT/RW or community network. Okay, we have 60,000 RT/RW-net in Indonesia. Because of that, International Telecommunication Union actually asked us to share our experience on building community network. So because of we have like 60,000 of it now. In the early days, many of us using Wi-Fi, but now they actually moving into fiber optics. This is the example. I'll show you the pictures. This is the example of fiber optics, a community network fiber optics. Let me see if I can. Okay. See, this one is in villages. You can see the house is not that very good. This actually villages in South Jakarta, far south. This is in Sukabumi, which is what, 2 hours drive from Jakarta, south of Jakarta. Okay, this is how they build these things. Or these are community based. Okay, so they actually building. They are now adopting fiber optics now in villages. The speed is quite high. Like this is FTTH, fiber to the home technology. So the download speed is about 2.3 gigabit per second shared by the community. Okay, depending on the number of users. Okay, so people actually building this thing. It's fiber optic to the village now today. Okay, there are a lot of pictures like this. You can browse, check this website, and you can see how they build it. And you can also check YouTube actually. YouTube, many of them actually uploading their experience building RT/RW-net fiber. Okay, see, this is so people actually sharing how they built fiber optics community network in villages. This is real. Okay, so people actually building the network in village. Okay, don't ask me about the legal aspect of this, but people actually build this. Okay, okay. Now I like to continue. So yes, we have 60,000 community network, and yes, we actually moving towards fiber optics community network. Okay, I need to tell you a little bit about the liberation of Wi-Fi in Indonesia. In the past, before Wi-Fi is liberated, people have to pay the government, the Indonesian government, about 2,000 US dollar per access point per year. So every year, every single access point have to pay about 2,000 US dollar per year. Okay. At that time, we actually, well, I have to say in polite words, I cannot use very straightforward words. At that time, with many of my friends, we actually educate many Indonesians how to build a low-cost, high-speed community network using Wi-Fi. Okay, because of that kind of experience, people actually invite us to run workshop in Bhutan, in Nepal, in South Africa, and many things. You can download the document from this URL. Okay, lms.onocenter.or.id/pustaka/docs, and then resume 2020 edited. Okay, I think I already download. This is the file. Okay, this is the file. Okay, if you like to see the YouTube files, videos, yes, you are welcome to click this URL on YouTube. But I like to show you some of the archive, the pictures. This is the pictures when I ran a workshop in Bangladesh. You can see this man in batiks, but I cannot read the single words here because this is in in Bangla, so I cannot read. This is the picture when I ran a workshop in Pretoria, South Africa. You can see this is a Pringles can, so we can make the Wi-Fi into longer distance. And this is a workshop on voice over IP in Bhutan, in Paro, in Bhutan, around 23, 25, forgot. Okay. Most of them using local traditional dress, and this guy is using local Indonesian traditional dress. And this one in the first World Summit on Information Strategy in WISIS in Geneva 2023. So I share how to build low-cost internet access. Because of this talk, many of during World Summit, many president and minister come to the World Summit from many countries. Because of that, people actually ask me to run a workshop in many of their countries. So after this, then I go to many countries, including this one is video picture during video TV interview in Ottawa, in Canada. And this one when this is a little bit crazy, because what you see here is base transceiver station, BTS, cellular. And this workshop was run in Professor Kancana Interlab. The person in what's that, blue t-shirts are from Bhutan. So I teach friends from Bhutan how to build their own telco, how to build their own cellular network using this kind of equipment. This is base transceiver station. Okay. Let me see. This is also taken at AIT, different years on voice over IP. This one taken in Penang, Malaysia, on how to build walk-bolik. The actual walk was borrowed from the hotel. So I borrowed the walk from the hotel to run the workshop how to make long distance connection. Okay. Okay. This is the past. This is the radio network. So the main problem with this is how to spread the knowledge to many people. So people will convince, they invest their own money, and they adopt the technology, and they build the technology, they build the infrastructure themselves using their own money. To be able to do this, those things, I need to write a lot of books. So the books is actually not for, what's that? For aiming for a professorship. No, the book is actually for spreading the knowledge. So as many people convince and put their own money building the technology. So I wrote a lot of books because of that. Okay, and also we run. Thank you very much for Institut Teknologi of Tangerang Selatan, because I'm able to run. Let me see this website for free. The website is open course, itts.ac.id. This is an open course website. People can register for free, and then they can get the they can access to the what's that course for free, and they can get the certificate for free. So this course can, some of the course is related to what I was telling you. Where is it? This is IPv6, IoT, Internet safety. Where's the network? This is cybersecurity. This is computer network. So the one that I told you on and on is the computer network stuff. Okay, you can get from this website and get the certificate for free. Okay, now because of the international effort, finally, many people from international community tell the Ministry of Communication and Information at that time is Mr. Hatta Rajasa, the minister. People telling him about the good stuff of Wi-Fi for long distance communication, for low cost internet access. Finally, 5 January 2005, Wi-Fi is liberated. Okay, you can check the story on this website. Let me see if I can get it. Copy and then paste. So this story is written by Richard Hughes from Canada, from IDRC, and you can read the story how liberation was performed, how a liberation process of the frequency was done in Indonesia. Okay, so most of the time when we do liberation, we fight. We are not really fighting in Indonesia, but actually the international acknowledgement of what we are doing, creating a big pressure to the Pak Hatta Rajasa, Mr. Hatta Rajasa, the minister. Because of that pressure, Hatta Rajasa finally signed an act that Wi-Fi can be used for free without license. So now today, people can use Wi-Fi for free in Indonesia. In the past, we have to pay like $2,000 per access point per year. Okay, so that's the one. Okay, because of that, Wi-Fi is liberated. Okay, now our job is not finished. I'll show you the problem. This is the problem. You can download Open Signal in Play Store. It can check the signal condition all over the world, including Indonesia. These are the signal in Indonesia. You can see this is Sumatra Island. You can see a lot of blank spot in Sumatra Island. Okay, this is the South Island is Java Island. The North Island is Kalimantan Island. A lot of blank spot in Kalimantan Island. Not much blank spot in Java Island, but if we zoom in to Java Island, especially the south part of Java Island, a lot of blank spot in south part of Java Island as well. This one is Kalimantan and Sulawesi, also a lot of blank spot. And this one is the worst part of Indonesia, the eastern part of Indonesia, Maluku and Papua. This is scary. Okay, not many signals. That means not many internet. And one time, I think last December 2020, the director for education in Papua province complained because they cannot perform school from home because 2/3 of the what's it? Not municipal. 2/3 of municipal in Papua, there is no cellular signal. So we are having problem with that. So the solution have been done since 7 years ago. We have been playing around with open base transceiver station. Open base transceiver station is like cellular network. Like we actually building a cellular network using open source technology. So basically the way it works is very similar to sound card, but this one is not sound card for sound. This is for cellular, for 2G, 5G, LTE. Okay, you can go to GitHub, look for use keyword 4G, 5G, LTE, and then you get a lot of source code for this kind of technology. Okay, if you want to do your own programming, I'll show you a little bit then. Okay, GitHub. I go to GitHub. Okay, if you want to build a 4G, 5G, you can. Let me. Okay, 5G. Okay, 5G technology. So you can this. GitHub shows about 3,700 application source code on 5G. So yes, we actually can build our own 5G because the source code is open actually. See, like this, API of main network function in 3GPP 5G core network. They open everything, so we can build 5G. If you like 6G, of course. You can build your own 6G. If you want to do your own programming, you can use GNU Radio. Let me use GNU Radio in Google. Googling GNU Radio. GNU Radio. It's very simple. See, this is how we program. It's very scary. The programming process is using graphics programming. It's not script. It's graphic. Click, drag, link, click, drag, link. Finish. We can have our own radio. Okay. All we need is the conversion from 1010 file in computer into the actual radio signals. It can be done using special equipment. The keyword is Blade RF, Lime SDR, Etus, YITS. Let me show you how much price how much the cost. Okay, this one is the Lime SDR. Lime SDR is the most cheapest. This is very cheap. I'm very surprised. Let me see where to buy crowd supply. I hope it shows the price. No. Okay. Doesn't show the price. No price on that one. Okay, but actually this price is the price of Lime SDR is very low, like around $300. So the price of this equipment is similar to your phone. Okay, let me see Blade RF. Blade RF. Let me see this one. The cost is about $420. So it's very affordable. So all we need only this one and computer, antenna, ampli if you like. Okay, this I like to show you what we do. Open BTS Papua. So this is the base station in Papua. installed by the help of Curtis Hamler. This is Curtis Hamler. He's the one who helped friends in Papua to build their own BTS. This BTS, base transceiver station, is the longest running BTS in rural in the world, in Papua. It has been running for 7 years now, I guess, without interruption. It's still running now. And then they replicate the BTS into like 13, I forgot, I think around 13 villages in Papua. And some people in other part of Indonesia, they actually adopting the same technology, but they move into 4G now. This actual BTS is GSM. This is the inside of the BTS. Because I ran a workshop on how to build these things as well. So this is the inside of the BTS. This aluminum packaging is the equipment to convert the digital into radio signals. This one. This is the software-defined radio equipment. The green one is computer, and the small one here is the amplifier. So that's it. Oh, this is a duplexer. So we need computer, duplexer, conversion from computer to signal, and this is the amplifier. That's it. That's the inside of BTS. And people can run this one. This BTS in Papua, okay? The one in Papua is run by school teacher in Bogendini, about 7 hours from Wamena. Okay, so we are looking at this kind of technology. So yes, we can build our own community cellular. And then the latest one, I try to educate people how to make school offline. Okay, it's very simple idea. Basically, we can use a Raspberry Pi 3, which is $35. You can get from online store. Let me show you what is Raspberry Pi 3. Okay, it's palm size server. So this is Raspberry Pi. Let me see if there is a palm people holding. Basically, it's what's that? Credit card size PCB server. So the size of the PCB is same as credit card or your identity card, similar. The cost is about $35, and we can build a local school server using this equipment. I did run Wikipedia, copy of Wikipedia in this server, and I also able to run Moodle e-learning in this server. As we know, Wikipedia is free and Moodle is free. So student can access the knowledge for free using this kind of equipment. Okay, the name of the software to run a local copy of Wikipedia is called ICAICST, while the e-learning server is Moodle box. I'll show you the Moodle box because it's very clear for the Moodle box. Moodle box. Okay, this is Moodle box. You can download the image for free. See, this is Raspberry Pi. You can download. Let me see where. Now, this one, Get Moodle Box. You can download the image for free. It will include the operating system, web server, everything, including Moodle into the image. So we can download the image, everything, and then we can install, and then the e-learning server is running on Raspberry Pi. We have tried this in several schools, and of course, it works. But to make distance longer, we normally connect an outdoor Wi-Fi, so the surrounding neighborhood can connect to the server without having to worry about paying the license and pay the telecommunication fee. Everything is free. Okay. Because of that, we run to empower we run e-learning and certificate in this website, LMS Ono Center, and open course is e-learning. Many of the video, I have around 2,000, more than 2,000 actually video in YouTube. I have two channels actually in YouTube, Ono Center, and the other one is cybersecurity. And also in this website, onocenter.sakamillennial.id. It's free. About 2,000, more than 2,000 video, and people can copy ebook and library from me. So people sending me hard disk and copy the hard disk for free. Basically, I try to lowering the cost for getting the knowledge. The major problem is not the cost now. The major problem is language, because most of the knowledge is written in English. When I copy to them, many of them actually complain to me. Pak Ono, do you have any books in Indonesian language? That's tough questions. So I really hope many of my colleagues, many of my students would like to write books and knowledge in Indonesian language, because that's what we actually need. Local knowledge in local language. That's the most important one. That's the most urgent one. At this time, having these difficulties, having this effort, finally, the international community actually give acknowledgements. For example, this one in 2005, when this is by Richard Hughes. Okay. When Wi-Fi is liberated, I have to type again. Okay, copy. So this is the international recognition. So basically, because of the people power, convince building the technology, and finally we liberate Wi-Fi. This is one. The other one is, sorry, this one, the postal service. Oh, sorry. Oh, sorry. Oops. Oops. Let me see how I can up. Let me search Google the easiest way. Postal Service Award. Yeah. Okay. So this only last year. Postal Service is an award given by, sorry, Postal Awards. No. Oh, wrong. Postal. Oh, this one. So Postal Service is the highest award given by Internet Society in recognition of Jonathan Postel. If you are internet technology, internet geeks, if you are involved in Internet Engineering Task Force, if you are involved in building the Internet, you will know who is Jonathan Postel. Jonathan Postel, basically the man behind the Internet, the man who built the Internet, the man who maintained the Internet standard, the man who maintained the early IP address, the man who maintained the early port numbers. When we numbering the ports, actually Jonathan Postel is the one who maintained everything. So he's the guy. Okay, and then because of his contribution, Internet Society gave the highest award to people in internet technology, named after Jonathan Postel. After Jonathan Postel, called Jonathan Postel Service Award. So this is the guy who received the awards. Okay, finally Indonesia received one because of sharing the knowledge basically with the Indonesian people on how to build the internet technology for free, for low cost, and hopefully we actually building the internet technology. So we are not aiming for the performance. We are aiming for as many people getting the technology, as many people convinced, putting their own money and build their own technology. So with that, I hope this will give you some insight for the direction of the research, not only for the quality of the technology, but also how to make the technology benefit for as many people as possible. Thank you very much. I give it back to Ms. VJ. Thank you.
Thank you for the wonderful presentation, Pak Bapak Ono. I got dizzy just by listening to your explanation and history. Yeah,
Dizzy.
I think, yeah, I got dizzy suddenly. Yeah, no wonder why people call you a legend, because you have been working on the issue for about 30 years and have shown the results that have been enjoyed by Indonesian people. Yeah, we do hope there will be more people with this kind of endurance like you, Pak. Thank you for this very wonderful presentation. And I have read your profile. And felt confused which one should be put and share here, because it seems like an endless list. Yeah. Thank you once again. So I think we can invite 1 or 2 questions for this session. Please, everyone, if you are curious about Bapak Ono's work, please post your question.
Very confusing presentation.
Very confusing list, Pak. I'm so amazed.
It's fun though. It's
Yeah.
very fun process.
Yeah, for you, yeah. That's great.
For everybody.
That's great.
For
Yeah.
everybody.
Yeah. Baik, Bapak Ibu, if you have any question, or you got confused just like me?
I'm sorry to make you confused.
Everybody's confused on posting what kind of questions that should be posted now.
Sometimes people are speechless.
Yeah, very speechless now.
No problem, no problem. You are welcome to send me email and Twitter. Okay. So if you have question later, feel free to send me email. I put my email in the chat box.
Okay, good.
Indo.net ID. The other one is ono at. Oh, I put directly to you, private. Oh, okay. I have to give it to everyone.
Okay.
My email is ono@itts.ac.id. Oops, wrong. ono@itts.ac.id or ono@indo.net.id. So feel free to send me email. I like to, not supervise, helping people to write books as well, because that's the key. If you like to write books, you can talk to me on how to write books. It's free. You don't have to pay. You have to pray. You don't have to pay. You have to pray for me. That's it.
That's wonderful. Okay, let's use Pak Ono as maximum as possible.
No problem.
Okay, thank you very much once again for the presentation today, Papa Ono. Hope you're always in a good shape and in innovating mode on.
Thank you.
Yeah, thank you. Okay, Bapak Ibu, ladies and gentlemen, another wonderful presentation will be delivered by Professor Dr. Burhanuddin bin Mahmud Abu Baidar. Professor Burhanuddin will share with us his work entitled Stage Identification and Classification of Lung Cancer Using Deep Convolutional Neural Network. Before we enjoy the presentation, allow me to share a little bit information about Professor Dr. Burhanuddin. He is a Deputy Dean and Associate Professor at University Technical Malaysia, Malacca. And he was graduated in Industrial Computing from University Technical Malaysia, Malacca as well. As mentioned previously, Dr. Burhanuddin bin Mahmud Abu Baider is currently working as Associate Professor and Deputy Dean of Research and Postgraduate Studies, Faculty of Information Technology and Communication, University Technical Malaysia, Malacca. He has completed his PhD in Industrial Computing from some university. His work experience includes appointed as Associate Professor at King Abdulaziz University, Saudi Arabia, Senior Lecturer at University Technical Malaysia, Malacca, UTM, and Lecturer at University Teknologi Mara, UTM, and Oban University. Without delaying any further, let's welcome Professor Dr. Burhanuddin bin Muhammad Abdul Baider. Professor Burhanuddin, the floor is yours. Can we have Professor? Okay, wait a minute. Mas Salif, can you find the professor? Oh, okay. While waiting for Professor, maybe if you still have questions to Bapak Ono and you're still curious about his works, you may still pose question. There's a comment from Mr. Taraknath Paul. Your invention, Pak Ono, are awesome. Up to the sky, sky is the limit. Thank you very much for the comment. Okay. Silakan Bapak Ibu, if you still have questions, please feel free. Mumpung Pak Ono juga masih di sini. We are still trying to connect with Professor Burhanuddin. Yeah, for your information, there will be another parallel sessions at 1 p.m. So we invite all participants to join the parallel sessions to listen to some shares of the work of our researchers friends. Bapak Septian Cahyadi, please, if you still have questions, that's fine. If you cannot activate your microphone, maybe you can type your question here in the chat room. Okay, Bapak Ono, are you still with us? Alif, can I? Hello, Pak Ono? It seems like Pak Ono is not around, Pak Septian. We will relay your questions to Pak Ono, ya. How far Pak Ono got the support from the government? Okay, we'll keep the question. Pak Ono, I cannot reach Pak Ono at the moment. Yeah, maybe we can collect the questions if you have questions about Pak Ono's work. Okay, well, while still waiting for the Professor Burhan, we still try to connect to Professor Burhan. I think we had better take a picture of us together. Would you please open your camera so we can take a screenshot together? Okay, we'll do it in 5 screenshots. This is the first one. Ready? 3, 2, 1, go. Okay. Let's continue to the next page. Would you please open your camera? Bapak Muhammad, Ibu Kartika. Okay. Mr. Abdul Rakib, would you please open your camera? Mas, Bapak.
Wait. Okay, I'm sorry for the technical errors, ladies and gentlemen. It seems that we can continue with the photo shoot session. Please open up your camera and look at your camera. We will start the photo shoot. Give your best smile. Okay, let's move to the second part. Would you like to open your camera, Mas Marwan, Mas Septian, Miss Christina Andriani, Mas Rizky Prasetyo, would you like to open up your camera? Miss Hesa, would you like to open up for a minute, please? Bapak Ngadimin, would you like to open up your camera? Yeah, all right. Okay, we will take an awesome moment to make a beautiful memory here. Okay, that's done. Thank you. Okay, the next, please, Miss Wulandari, would you like to open up your camera? We have photo session here with all of the speakers. Pak Rido, some speakers haven't activated the camera. Latifa, would you like to open up your camera? Verina. Oh, so many speakers. Yudi, Firly, would you like to help me to activate your camera, please? Okay, thank you so much. We are waiting for the keynote speaker.
Okay, ladies and gentlemen, we're going to still try to connect to Professor Burhanuddin. So I think we can have a break for about 10 minutes and get back here to join the presentation. Thank you very much. Okay, Bapak Ibu, ladies and gentlemen, we're waiting for the connection with Professor Burhanuddin. We're going to give you a quiz. And there will be a kind of, what do you call it, a reward for those who can answer the questions. Pertanyaan ini berlaku buat mahasiswa nggak? Nggak ya? Okay, just for the participant. Okay, the question is, who is the chairman of Institut Teknologi Tangerang Selatan that organized this conference? The question is, who is the chairman of the Institut Teknologi of Tangerang Selatan?
The participant can answer, Miss.
The participant, especially.
Okay. Dr. Hanafi.
Dr. Hanafi, yay, you are correct. Oh, you, Ibu Sumarni, yeah.
Yeah.
You know him so well. I think it's an unfair. Okay, the official will contact you, Ibu Sumarni, for the reward. Thank you for the participation.
Okay, thank you.
Thank you. Okay, the next question. Our first keynote speaker today is Bapak Ono W. Purbo. What W stands for?
Boleh menjawab?
Boleh, Bapak Rizky, silakan.
Widodo.
W stands for Widodo. Thank you. That's a very easy question. The admin will contact you for the reward. Thank you, Pak Rizky. So I'm still thinking about the next question. I think this is a hard question, yeah? The next one. I wonder who knows the answer of it. Who is the name of the co-chair of this conference? Who is the co-chair of this conference?
Halo,
Looks like yes, Pak Rahmat.
Agung Budi Prasetyo.
Bapak Agung Budi Prasetyo, is that correct? Okay, correct. Okay, thank you, Pak Rahmat, for the answer. I think that's enough. Is there any more reward? Oh, Pak Agung bangkrut katanya nanti. Okay, thank you for the participation. The admin will contact you for the reward. Thank you. So, have we got the connection with Professor Burhan? No? Not yet? Okay. We'll extend the break to another 5 minutes. Please take your time, everyone. Thank you.
Assalamualaikum and good afternoon. Hello.
Waalaikumsalam warahmatullahi wabarakatuh. Welcome, Professor Burhanuddin.
Yes, I'm Burhanuddin here from
Yeah.
University Technical Malaysia, Melaka.
Yeah, we have introduced you to the participants. I think.
Thank you.
Are you ready with the presentation?
Okay, can I share my screen?
Sure. Yeah, Bapak Ibu, ladies and gentlemen, let's welcome Professor Burhanuddin from UTM. Thank you.
Yeah, 1 second, please. My screen, or can I share my slide? Can you see my screen?
Yes, we can see it, sir.
Oh, you can see, all right. Okay. You can see my slide, right? On multi-criteria deep learning.
Yes, sir.
Okay, good. How about this paper?
Yes, sir.
All right, good. Okay, thank you very much. Assalamualaikum warahmatullah and good afternoon. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala ashrafil anbiya wal mursalin wa ala alihi wa sahbihi ajma'in. Dear chairperson, our moderator, dear Professor Dr. Hanafi, Chairman of International Conference on Artificial Intelligence and Computer Science Technology, ICAICST 2021, Bapak Agung Budi Prasetyo, Co-Chair, committee member of International Conference on AI and Computer Science, Technology, ICAICST 2021. Dear Professor Ono, President and Management of Institut Teknologi Tangerang Selatan, dear Professor, Doctor, Lecturer, students, conference participants, ladies and gentlemen. First of all, I would like to thank ICAICST 21 organizer for inviting me to deliver a talk today. Thanks to all participants of this conference. I am Burhanuddin Muhammad Abu Baider. I feel very honored to present one important topic today in the conference, an important topic which is on multi-criteria deep learning approach for feature selection and classification using a neural network. Okay. All right, I'm from UTM, University Technical Malaysia Malacca. I'm a director of International Center, and very brief about my university, because maybe you would like to know about my university first. Okay, only one slide I would like to share on our university, which is established on December 1st, 2000. We are the first technical university in Malaysia and 14 public university in Malaysia. We have 8 faculties and 1 institute. We are specialized in engineering, technology, and management. We offer diploma program, bachelor's program, master, as well as PhD. And we are ranked in top 10 in Malaysia, and we are ranked in 1001 to 1527 in the the world ranking 2021. The is a Times Higher Education ranking. We are top 500 in QS Asia ranking, and you can find more detail about our university in www.utem.edu.my. All right. You can hear, right? Is it clear? My voice?
Yes, sir.
All right. Thank you. So first of all, I would like to introduce what is deep learning. Okay. Actually, artificial neural networks, or ANN, mimics the working of human brain in processing data. Okay, machine learning technique that teaches computers to do what comes naturally to humans. Okay, and it is a flexible model with an input and output type and size, and it can be nonlinear, hierarchical, abstract, or representation of data. Deep learning represents a neural network that wants to solve a complex problem that requires deeper learning with more hidden layers. If you can see this Venn diagram, you can see artificial intelligence is the big portion, and then inside that is a machine learning, and inside machine learning is a deep learning. If you look at artificial intelligence, actually it's the ability of a machine to mimic human brain. Okay. And then what is machine learning? It's the application of artificial intelligence that try to learn from the human and allow system to learn automatically and improve from the experience. But if you look at the machine, they are not based on the experience, but based on the historical data. Then we come to the deep learning, which is the application of machine learning that use complex algorithm and deep learning. Okay, now we want to know why we want to mimic the human brain in artificial intelligence, in neural network, as well as deep learning. If you look at the human brain, we are having aging issues, aging problem, right? When we become old, so our thinking skill, our cognitive skill will be reduced slowly. And due to other factors, for example, Alzheimer's, a brain tumor, short-term memory loss, and so on. So our brain will be deteriorate from time to time. Whereas if you look at a machine, okay, machine, we can have more powerful machine. Even the machine getting old, we can change the processor, we can change the RAM, we can change the hard disk, and so on. And it can be a very powerful machine. And we, as a human, we base on our experience, but for the machine, it based on the historical data they are already stored in their memory. That's why if you can see over here, this is a simple neural network that you can see where we have the input and then we have the layer and then it generate the output. Whereas in deep learning, you can see that they have more hidden layer, which I will explain in later slides. All right. Before we go to more detail, why this is important for us to have machine that can mimic or can learn from the data, we want to see the historical side and evolution of this artificial neural network as well as deep learning. Okay, this is the deep learning history and evolution from 1943 to 2021. Okay, if you can see, it started early in 1982 by John Hopfield, creates a Hopfield network, which is a recurrent network. But when you look at this network, is only one way, like one-way thinking. Then in 1982, later, proposal of backpropagation is given by Paul Werps, publicly proposed the use of backpropagation for propagating errors during the training of neural network. Then in 1985, we have another scholar, David H. Ackley, Geoffrey Hinton, and Terence Sajauki create a Boltzmann machine, which is a stochastic recurrent neural network, which this neural network has only input layer and hidden layer, but no output layer. But then the output can be the input to other neuron. So this is the beauty of this Boltzmann machine. I'm sorry. Okay. Then later in 1989, if you can see in 1989, it's come with the convolutional neural network, which using a backpropagation. Okay, where Yan Li Chun used backpropagation to train the convolutional neural network to recognize handwritten digital. For example, my handwritten compared to your handwritten, we can recognize easily this handwritten belongs to who. He used the convolutional neural network to detect this. Then later you can see the universal approximation theorem comes at the middle of 1989 to 1991 by George Cybenko, published earliest version of the universal approximation theorem in his paper. In his paper, he proves that feed-forward neural network with single hidden layer containing finite number of neurons which can approximate any continuous function. Then they have a vanishing gradient problem appears where you can see after the 1990s by Step Hochreiter, which he identifies the problem of vanishing gradient, which can make the learning of deep neural network extremely slow and almost impractical. Okay, and you can see this theory evolve from time to time, where you can see at the bottom of my slide in 1997, we have long short-term memory theories, and then GPU revolution begins, means that graphical processing units. Earlier we call as central processing unit, CPU. This is graphical processing units, where we have more powerful machines to process data and to produce important decision making to people. And it comes with deep belief neural network in 2006. Is a Russian Salakutinov Osindero and Tel published the paper, A Fast Learning Algorithm for Deep Belief Nets, in which they stack multiple radial basis network together in the layers and call them as a deep belief networks. Okay. And now you can see in 2004, this is recent until 2019. In 2004, the birth of generative adversarial neural network, which created by Goodfellow and Gunn, where it has an ability to synthesize the real data. When we talk about the data, we have a lot of data in the memory of the computer, okay, in the cloud and so on. So that data we can analyze, but then after we analyze, how we want to combine and come out with the solution or the decision. So that's what we call as a synthesis. And he introduced this theorem to synthesize data using adversarial neural network. But then in 2016, we can see more enhancement of this theory, where they have AlphaGo, which beats human already, where they have deep minds or deep reinforcement learning model, which beats human champion in the complex game of go. In 2019, we had Trio Win Stewart Award by Joshua and Bangalore, Geoffrey Hilton, and others, where they come up with where they win Turing Awards in 2018 for their immense contribution in advancement in area of deep learning. And now if you go to the Google or Google Scholar, if you Google, for example, when the pandemic comes in 2019, you Google COVID and deep learning, you see, I put the example over here. There are many papers, okay, and 179,000 results that come out related to deep learning and COVID-19, where they study COVID-19 issues during a deep learning theories. So this is where we have to focus, and we have to put more, we have to emphasize how can we learn more about this deep learning, all right? So with that, I believe that we get a motivation to learn about a deep learning. Now, I want to show a very simple example, a difference between human brain and deep learning. All right, if you can see over here, okay, neuron in human brain transfer signal to each neighbor neuron similar to deep learning. So input value being transferred to node in every layer. If you can see over here in human brain, a human brain contains 100 billions of neurons in our head. And each neuron connects to about another 100,000 of its neighbors in our brain. And the signal from one neuron travels down the axon and transfer to the dendrites of the next neuron, and every signal passes through the synapse. If you can see in this diagram, this is the example where we have one neuron, and then it's a fire the output, okay, and then go to the another neuron, and then from the another neuron go to another neuron. For example, like one small children, he learn about something. For example, he learn about alphabet A for apple, B for ball. So he tried to associate A with the apple, and then from there he connect from A to B, and then B for ball, and so on. So once he get one knowledge, one data, and then he can get another data by associate with what he learned before. So this axon, this neuron grow and grow and grow in our brain. But then if you didn't think, if you did not use the brain to think about something, then slowly that neuron will die. That's why very important for us to learn. Every day we learn something, okay? Now I'm going to compare with this theory with the artificial neural network. So if you can see over here in deep learning, we have from an input through the activation function, which will get the output. Every output will be the input for the next layer, and the neuron nodes gets the signal or input layer passes through the network. So the neuron delivers the output signal, and then it evolves another neuron to another neuron and to another neuron in different layers. So when we transfer this artificial, this biological neuron in our brain to the artificial intelligence or artificial neuron over here, you can see that we have many inputs in our life. In our life, we have many inputs. So it's same thing. If you look at the cloud, we have a server. In the server, we have many inputs data. All right. And then every data have their own weight, means that they related to what? Is it related to the weather? It's related to the cost. It's related to the time, and so on. All right. And then the input with this weight, and then have some calculation, and then it will fire output. And then from that output, it trigger another input, and so on. Okay. That's what I mean from this diagram. All right. Then after that, we have a classification. Okay, in human brain and deep learning classification, we can see over here, the human brain is a far more complex web of diverse neurons where each node performs a separate task. Okay. And deep learning transcends human ability to process a large volume of data. Okay. Deep learning consists of artificial neural networks that are modeled on similar networks present in the human brain. Deep learning also use deduction, but in a linear, basic, and one-dimensional way. Okay, all right. So in a human brain, we have the experience. From my experience, I can suggest or I can give the idea. All right. But when we do look at the machine and deep learning, so it is about the volume of data. We have a volume of data. From that data, we can try to classify this data belongs to which group. All right. As an example, training in artificial neural network is to classify lions as a dangerous, might make them sensitive only to the lions. A bear cannot be classified as dangerous automatically. And then training them to identify a cat will only make them recognized as a cat, but not deduce that a leopard belongs to the cat family. That's why you can see over here at the diagram here, we can see which is cat, which is lion, which is leopard, like what human think. All right. And why we need this deep learning actually? Okay. Why? Because we need a better algorithm to understand the data that we have in the cloud. And also we want to handle a complex problem. When we want to handle the complex problem, deep learning can perform a complex operation easily while machine learning cannot do it. All right. Machine learning maybe can use other algorithm like n-colony algorithm or can use swarm intelligence and so on. But in deep learning, we using artificial neural network, we are trying to mimic how humans think. Okay. And that's why we have works with a structured and unstructured data. And with the computing power, GPU and GPU, we are able to achieve it. A contemporary data science method to keep up with the growth in data, older learning algorithms, and it is no longer performing right now. And for using this deep learning, nowadays we have many tools available. For example, we have Crush, we have Pandas, we have scikit-learn, we have TensorFlow. All this we can use in our research area. If you can see over here, we have labeled the data. For example, you can see the amount of data and then the performance. As I mentioned just now, there are many other learning algorithms in machine learning, but it only the amount of data increase, and then it will be flat like this, the graph that I show in blue in color. Whereas if you look at the red color curve in this graph, when we have a lot of data, huge amount of data, then we can use deep learning. So in our in today life, when we have a web, we have big data, we have a good cloud, and then we have huge number of data. You can see the transaction over internet. Okay, in every second there are millions of transactions. So there are many data stored in the cloud. So that's why we would like to use deep learning, where you can see when we have more data, huge amount of data, means that when my axis increase on the amount of data, you can see the performance or the learning from the data that I have will be higher using deep learning. That's why we would like to have a deep learning. Today, the chairperson is Miss Yanti Wijaya, am I right? Hello?
Yeah,
Okay.
hello. I'm sorry, I missed send the chat. I'm sorry.
Yeah, it's okay.
Just ignore it. Just
Yeah,
ignore it.
can you please play my video on deep learning? I already
Okay.
sent.
Alif, can you play the video?
Because if I play from here, from Malaysia, maybe the sound will not be very good.
Yeah, we're trying to attempt it, sir.
Yes, sure.
Yeah.
Yeah.
Play the video.
The first video, which is deep learning in 5 minutes. I have given 2 videos. One is deep learning in 5 minutes. Can you?
Ada? Okay, wait a minute.
Ada, boleh kongsikan?
Yes, siap.
Terima kasih.
5 minutes.
Yes, I can see from here, Malaysia.
Okay.
Thank you. Can you hear the sound? Can hear sound of the video?
No, we cannot. No, we cannot.
Because you play from your place, right?
Yeah.
Yeah. Can you hear the sound of the video in YouTube? Or yeah.
How Google translates an entire
it's okay now.
different language in a matter of seconds, or your phone gallery groups images based on their location.
I can hear clearly from Malacca,
deep learning.
Malaysia.
But what
Thank you.
exactly is deep learning? Deep learning is a subset of machine learning, which in turn is a subset of artificial intelligence. Artificial intelligence is a technique that enables a machine to mimic human behavior. Machine learning is a technique to achieve AI through algorithms trained with data. And finally, deep learning is a type of machine learning inspired by the structure of the human brain. In terms of deep learning, this structure is called an artificial neural network. Let's understand deep learning better and how it's different from machine learning. Say we create a machine that could differentiate between tomatoes and cherries. If done using machine learning, we'd have to tell the machine the features based on which the two can be differentiated. These features could be the size and the type of stem on them. With deep learning, on the other hand, the features are picked out by the neural network without human intervention. Of course, that kind of independence comes at the cost of having a much higher volume of data to train our machine. Now, let's dive into the working of neural networks. Here, we have 3 students. Each of them write down the digit 9 on a piece of paper. Notably, they don't all write it identically. The human brain can easily recognize the digits. But what if a computer had to recognize them? That's where deep learning comes in. Here's a neural network trained to identify handwritten digits. Each number is present as an image of 28 times 28 pixels. Now, that amounts to a total of 784 pixels. Neurons, the core entity of a neural network, is where the information processing takes place.
Walaupun boleh diisinya ada orang lain ya, tapi sifat dasarnya itu kayak kasar dan perakar. Jadi nggak bisa ada cara hati pertua begitu di lain pihak. Keluarga boleh juga ternyata nggak suka sama suami. Meskipun mereka
representing a digit. Information is transferred from one layer to another over connecting channels. Each of these has a value attached to it, and hence is called a weighted channel. All neurons have a unique number associated with it called bias. This bias is added to the weighted sum of inputs reaching the neuron, which is then applied to a function known as the activation function. The result of the activation function determines if the neuron gets activated. And every activated neuron passes on information to the following layers. This continues up till the second last layer. One output layer corresponds to the input digit. The weights and bias are continuously adjusted to produce a well-trained network. So, where is deep learning applied? In customer support. When most people converse with customer support, conversations seem so real. They don't realize that it's actually a bot on the other side. In medical care, neural networks detect cancer cells and analyze MRI images to give health results. Self-driving cars, which like science fiction, is now a reality. Apple, Tesla, and Nissan are only a few of the companies working on self-driving cars. So, deep learning has a vast scope, but it too faces some limitations. The first that we discussed earlier is data. While deep learning is the most efficient way to deal with unstructured data, a neural network requires a massive volume of data. Let's assume we always have access to the necessary amount of data. Processing this is not within the capability of every machine. And that brings us to our second limitation. Computational power. Training a neural network requires graphical processing units, which have thousands of cores, as compared to CPU and GPU, or of course, more expensive. And finally, we come down to training time. Deep neural networks take hours or even months to train. The time increases with the amount of data and number of layers in the network. So, here's a short quiz for you. Arrange the following statements in order to describe.
Yeah, I think can stop the video.
A, the bias is added. B, the weighted sum of the inputs is calculated. C, specific.
Let me share my screen again. Can you stop sharing?
Yes. Yeah, we're on it.
Thank you. Thank you. Let me share again my screen.
Okay.
Can you see my screen now?
Yes, sir.
Yeah, okay. All right. Let me continue on my screen.
Okay.
Right. Now we would like to see how this artificial deep learning works. Okay. Can you see at my screen how artificial deep learning works?
Yes.
Ms. Yanti? Okay, thank you. So our estimate, artificial intelligent brains has neurons just like animals. So the circle are used to represent them. So we can see here the circle, okay? We have 3 circles over here, and then another 1, 2, 3, 4, 5 circle over here, and another circle over here. So the term deep in deep learning refers to the presence of multiple hidden layers to form feature selections. So there are 3 types of layers are used to group the neuron for a very basic one. So if you can see over here, this is the input, and then from the input, it will fire to the hidden layers, and then it will fire the output, okay? And then if I take this hidden layer, if I extract it to another slide, if you can see over here, we have the 1 layer of input, and then fire to the another layer of output, and then we can fire to more layers to the right hand side. So each connection between 2 neurons is represented by a numerical value, which we call as a weight. And a separate weight W is assigned to each connections between 2 neurons. So we have neuron A, for example, over here, and we have another neuron. So this is the relation between neuron 1 and to neuron 2 with the connection with the weight 1, 2. So we have 1, 2 over here. I have this neuron 1 to another neuron 1 connecting by the weight W1, 1. And another neuron, for example, here, neuron 1 to neuron 3 with the connection of weight W3. So a separate weight W is assigned to each connection between 2 neurons. There are indices for each of these weights, and the number of neurons in the layer from which the connections origins is represented by the first value of the indices, while the number of neurons in the layer to which the connection leads is represented by the second value, and it evolves, it go to the next layer in the deep learning. So the activation function of each neuron is unique, and without mathematical reasoning, these functions are difficult to understand. Means that in between this to this, there are some mathematical formula that they use to connect between these 2. Okay. So if you can see over here, the most popular types of deep neural network is known as convolutional neural networks, or we call as CNN or ConvNet. Okay. Because some of the procedure in the toolbox that they use, they call as ConvNet. It's well suited to the processing 2-dimensional data such as the image. For example, we have image. So image is 2-dimension. For example, like cat image. So from that image, it's very suitable for us to use this convolutional to identify this image belongs to what. Okay. So CNN works by extracting features directly from the images that I have mentioned just now. Convolutional neural network learn to detect different features of an image using tens or hundreds of hidden layers, and every hidden layer increases the complexity to classify the networks. For example, the first hidden layer could learn how to detect edges, and the last layer learns how to detect more complex shapes specifically catered to the shape of the objects we are trying to recognize. That's why if you can see in this figure, how we have the images, and then from the images, we try to identify the features of selection, identify region of interest, and then start to put as the input x1, x2, x3, and then we learn from the data until we can see this data belongs to what? This image either belongs to flower group, belongs to cup, belongs to car or vehicles, or belongs to the tree, for example. So we can classify. Why? Because we have feature of flowers is different than feature of cups, which is feature different than feature of transport on the road, and which is different than the tree in the jungle, for example. Okay. All right. Now let us look at the deep learning network architecture for multi-criteria classification that I would like to share in my topics, where it proposed by Geoffrey Hinton in 2006, and it is a classified as a deep generative model that is trained by stacking a series of restricted Boltzmann machines. That's why you can see when we have the input that is stacked at the hidden layer 1, and then stacked to the hidden layer 2, and stacked to hidden layer 3, until we reach the output layer. So we have restricted Boltzmann machine 1, and then we have restricted Boltzmann machine 2, restricted Boltzmann machine 3, and so on. Okay, so it is also an unsupervised, because we don't know what output will be looks like, right? We don't know. For example, like I give in earlier in this slide, if I give you the input and we don't know this input belongs to what? Is it belongs to flower, or belongs to cup, belongs to car, belongs to tree, or it doesn't belong to any of those? So it is unsupervised network. So that there are no intra-layer connections in between, and hidden units represent features that captures the correlation which is in the data. It was popular before, but due to emergence of many deep learning algorithms, deep belief networks have been rarely used, but the theories and the groundbreaking methods also been used, and there are many scholars hybrid this Boltzmann machine technique in their research area. All right. When we look at this deep learning network architecture is trained as follows. We give the steps how it been trained. So the first restricted Boltzmann machine trained to reconstruct its input as accuracy as possible. And then the hidden layer of the first RBM is treated as the visible layer for the second layer, and the second RBM is trained using the outputs from the first RBM. This process is repeated until every layer in the network being trained. And each RBM layer learns the entire input, and it can be fine-tuning using a deep learning architecture. That's why you can see over here at the first layer, at the second layer, at the third layer, and it involved to other layers. All right. So if you can see over here, deep learning uses representation learning to summarize, also known as a feature learning to map input feature analogs to prediction variable in traditional statistics to an output. And this figure shows the mapping process occurs inside the multiple connected layers, which each contain multiple neurons. And each neuron is a mathematical processing unit combined with the other neurons, which is designed to learn the relationship between the input features and the output. Okay, so you can see over here just now I have shown you a neuron which consists of the input and then respective weight, and then we have some of the learning algorithm over here. This is where the mathematics or the statistics come on the calculation part, and then it will fire the output, right? So if you look at this diagram from the previous diagram, we come up with this diagram. Okay, I would like to share one paper with you right now, written by Andrews and Marius. Okay. All right. This is the paper written by Adrian and Marius, where he has put the figure just now. Okay, this is also just a motivation for all the participants of the conference. If you look at this paper, only 3 pages, okay, only 3 pages, and can publish in intensive care medical journal. So it's not difficult for you to write papers. There are many researchers who want to do master degree, you want to do PhD degree, then you'll be thinking very difficult to write a papers to publish in reputed journal. But actually not that difficult. You see this author, they published in Springer Workblad in 2019, and this is Intensive Care Medical Journal in 2019. They published by only 3 pages. So if you can see, the title of the paper is Neural Network and Deep Learning, a Brief Introduction. You can go to Google Scholar, you type this title, you will get this paper for free. Okay, so they have mentioned about the artificial intelligence, where it refers to the theory and development of computer system able to perform tasks normally requiring human intelligence. And if you can see in this paper, if you read, they have mentioned that each neuron is actually a mathematical model, okay, and mathematical processing unit, and it combine and from the input features, and then it fire the output. If you can see over here, okay, is contain the mathematical calculation and also statistical calculation. All right, and if you go to the second page, you can see the diagram that I have shown you just now, and then they explain about this diagram, and then finish. That's all, only 2 pages. And then you can see in the third pages only the references, and in fact the contents of this paper only in 1.5 page. All right, so it's not difficult for you to write papers, publish papers in the journal, or attending conference by written the papers. Okay, let me back to my presentation. Let me continue. All right. Okay, this is what I have mentioned about how we come out with the mathematical modeling. Okay, how we come out with the mathematical modeling. If you can see over here, first we describe the real world, okay, problem. After that, we specify the mathematical problem, because every day in our life, we use our brain to calculate. For example, this morning, you want to eat something. So for sure, you will calculate how much I have the money and how much I have to spend for my food, how much should I spend for my drinks, and how much should I spend for the delivery, because people will deliver at home during this COVID-19 pandemic. So you do the calculation. So same thing, we have a data in a cloud, we come up with some mathematical problem, we formulate the mathematical problem. After we formulate, we solve the mathematics, and then we interpret the solution, then we evaluate the model, and then report on important decision making. That's why we can see, if you can see over here, it starts from the deterministic model, where it come up with the relationship between the input and output of the system. And then this relationship may or may not vary from time to time. For example, when I put the data in a grid in my database, in my server, when I put in the table, so I have column 1, column 2, column 3, column 4. So for sure, they have relation between column 3 and column 6, column 6 and column 8, column 7 and column 5, and so on. All right. So we try to identify their relation. And in the real world, not everything we have a relation. Sometimes we don't have a relation. That's why it come up with some stochastic model. So it can be a set of relationship between the input and output of a system, where both the inputs and outputs are random variables, and the relationship can be also random variable. So it can be linear, can be a non-linear, can be a polynomial, can be a non-polynomial, can be a parametric where it follow the normal distribution, follow Weibull distribution, or it can be a semi-parametric, or it can be non-parametric measures as well. All right. So if you can see over here, there are more mathematical modeling in deep learning. I don't want to go in deep on the mathematical modeling. Okay. There are many mathematical model, many equations that we can use to calculate between these table 1 and table 2 and table 3 and so on in our raw data. Okay. And even we can use the Bayesian neural network learning and so on. And this is the approaches to Bayesian neural network. Either we want to use Monte Carlo dropout, or we want to use stochastic weight averaging, or we want to use Gaussian, Gauss-Jordan, or other techniques that we would like to use to represent this data in the matrix form. For example, we have matrix 1, 1, 1 to matrix 2, 2, 2 to matrix 3, 3, 3, and so on. Okay, until we reach the final output. Okay. All right, let us look at the multi-criteria deep learning applications where we can apply this multi-criteria deep learning. There are many scholars using in aerospace and defense where they use deep learning to identify objects from satellites. When they are at the satellites, they try to predict what is this object from the satellites. They locate areas of interest and identify is it safe or unsafe zone for troops. It interprets and responds to outside environment by processing data from the sensors, including cameras, radar, and in the aerospace and defense industry, they are using this deep learning like crazy now. They use deep learning technology to consider many factors or criteria, including takeoff, landing, and navigation in autonomous planes. Okay. And even they have unmanned vehicle now. All right. And next we look at the automated driving. For example, this is the very first driving car used neural network to detect lane lines, segment the ground, and drive. It was called Alvin and was created in 1989, where they used deep learning to detect objects automatically, such as stop signals, traffic lights, people, trees, and other things. In addition, deep learning is used to detect pedestrian, which helps to decrease the accidents. And the criteria captured by using 3 sensors. Okay, if you look at this car, they use the camera, they use the LiDAR or light detection and ranging, and then the radar, which is radio detection and ranging. And now they have other sensors that connect to GPS and so on, where they can find from one destination to another destination. You can see even in finance, they use for the automation process, for example, they want to do the analyze the trading strategies. They want to do for financial security, stock market prediction, loan application evaluation, credit card analysis, fraud detection, and so on. For example, when people want to do transaction with the bank using the internet, they can try to identify this person is doing genuine transaction or he is a fraud and so on. And also you can see other applications such as industrial automation, in industry, in manufacturing, and even the agriculture, they use these deep learning theories. Other than that, now it's very famous. They use for feature extraction and classification approach with artificial neural network, where they use for the optimization to design of the deep neural network used to handle the large amount of data created by our time stretch imaging flow using cytometer, and where it used to upgrade the performance of both software and instrument, for example. And also nowadays they're using for medical research, example of cancer research using deep learning to automatically detect the cancer cell. Teams at UCLA built an advanced microscope that yields a high-dimensional data set used to train a deep learning application to accurately identify cancer cell using multi-criteria features. For example, with the image want to detect this, for example, breast image or lung image, right? We want to see any cancer spot in that image or not. where they develop an artificial intelligence powered device that detects cancer cells in a few milliseconds, hundreds of times faster than previous method. Because when you human or doctor use his naked eyes to detect or to identify, sometimes maybe he cannot identify, but when they use the machine, which is hundreds of times faster than previous method, and with that speed, the invention could make it possible to extract cancer cells from blood immediately after they are detected, which could in turn help prevent the disease from spreading in the body, because time is very important. For example, cancer image, if we didn't detect at the correct time, then very fast it can spread from cancer stage 1, can be cancer stage 2, can be to 3, or can be at 4. I would like to share the paper that written I and my student and I have written on lung cancer paper. Okay, we have published this paper in measurement journal by Elsevier. This is my PhD student, Muhammad Shakil, and this is me, Burhanuddin. You can see together with my colleagues from UTM, Professor Ishaq Desa. Okay, you can see over here, we are trying to detect the lung cancer. Lung, you know, paru-paru. In Indonesia, you call what? Paru-paru? Yeah, I think paru-paru. In Malaysia, in Malay, they call paru-paru or lung. Okay.
We call it paru-paru as well.
Yeah, paru-paru as well. Thank you. So for the COVID, it will, you know, it will attack this lung easily. Okay.
Yes.
So you can see our paper. We want to detect at the lung. You give us the image of that lung from the CT scan. Then from the image, we want to identify it is 0 or 1. 0 is not cancer and 1 is cancer. It's very simple. Okay. How we do that? We use deep learning, which is trained using a neural network. If you look at this paper, it's received in 2019 and published recently in May 2019. At the beginning, we thought want to put lung of COVID-19 and so on, but when we tell that this is the COVID-19, many medical doctors will refer. So we don't want them to refer. Maybe we are not very good enough in medical terms. Then that's why we didn't put about the COVID-19 and so on. But however, if you read at our paper, it is already give the detail about how the analysis been conducted. I don't want to read all these 11 pages of the papers. Let me go through and show you. This is the images of the sample of lung cancer in CT image. When the patient use CT scan to scan their lung, so this is the example of the lung, the images. All right. So when you get these images, what we do, we get these images. So we get the sample of images, and then we have a pre-processing. Why we have this pre-processing? Because during a CT scan scanning process, when we scan the image, there might be a lot of noise, a lot of errors, and so on that we have to remove. That's why when the lung image come at this pre-processing stage, we remove the noise, and then this is the histogram of image, and then this is the quality enhanced image. Why we want this quality enhanced image? Because we want to identify either this is cancer image or not cancer. All right. Then we go to the next stage. In the next stage, we use a segmentation using improved profuse clustering technique, IPCT, based on the spectral superpixel clustering. Okay. And here we already have the segmented image just now, and then we can see the any weird criteria or any abnormal criteria at the image, for example, over here. So we can see over here, and then this is the image, detected image, and then finally become on the segmented image. Once we have the segmented image, then we have a feature extraction where we identify this region of interest. Once we identify this region of interest, then we come to the feature extraction, and then from here we use the deep learning. Why? We use the deep learning to classify using a deep learning theory. So is this image is 0 or 1? Is cancer or not cancer? All right. So this is all about our paper, just to identify is 0 or 1, not cancer stage 1, stage 2, stage 3, stage 4, but only it is 0 or 1. It is a cancer or not cancer, 0 or 1. So to identify is it 0 or 1, so there are criteria. So based on the criteria that we have, means that in the database we have huge number of data on the lung images that identified by doctor. All these images is cancer image. So we do a comparison with all that cluster A, for example, and identify is belong to cluster A or belongs to cluster B, where cluster A is not cancer and cluster B is cancer. That's how we do the cancer prediction. All right. You can read this paper. Okay, you can download and you can read this paper later when you have a free time using a Google Scholar. And then you just type in Google Scholar lung cancer detection from CT image using improved profuse clustering and deep learning instantaneously trained neural networks. So you can get the paper already online. All right. And let me go back to my slides about our paper. I have another video where we will show you in detail. I would like to show you in detail on these stages how this clustering been done, okay, using a video. So please, I would like Miss Yanti Vijaya, could you please help to play a second video?
Yes, yes, sir.
My
Right on
time
way.
until got another 10 minutes or half an hour?
It's nearly over actually.
Oh, I see.
Okay.
Then you want to play the video or?
Yes.
It's okay?
Sure.
With your time?
Yeah.
All right. Thank you.
And we've been working on a project at the University of Toronto under the supervision of Professor Jackson and with the help of radiologist Dr. Barfett at the St. Michael's Hospital. This is early stage lung cancer detection, training a deep convolutional neural network with patches from synthetic frontal chest radiographs. Lung cancer is caused by abnormally behaving cells that either grow too fast or do not die regularly enough, causing them to grow into and destroy neighboring cells. These cells form tumors, which are commonly called nodules when they're less than 3 centimeters in diameter. As of 2018 in Canada, lung cancer has the highest projected incidence and mortality rate of all cancers, and also one of the lowest 5-year net survival rates, with about 50% of diagnoses occurring during stage 4 of the disease when the cancer has already metastasized. Since early detection is crucial for good prognosis, this project focuses on the problem of detecting lung nodules in early stages. There are several diagnostic tools used by doctors and radiologists to detect lung cancer. In this project, we'll be mainly focusing on X-ray radiographs and CT scans. X-ray radiographs are an affordable and accessible method of visualizing a patient's body, which make them a common method for preliminary cancer screening. Radiographs are grayscale images that capture the amount of X-ray radiation remaining after traversing the tissues of the body, which have various attenuation coefficients. X-ray computed tomography or CT scans serve as manipulable 3D models of the patient's body and are reconstructed using X-rays taken from different angles. In this project, we create synthetic X-rays by inserting nodules into CT scans to generate a large, diverse data set to train a neural network to detect nodules. Due to the higher attenuation of bone tissues, they appear bright in the radiographs. In contrast, lungs, which consist of air mostly, appear dark since air has very low attenuation. To create the X-rays, CT scans, which are stored in Hounsfield units, are converted to attenuation coefficients using this formula. These are examples of radiographs without nodules. On the left, we have a real one, and on the right, we have a synthetic one that we generated using a CT scan. And these are some radiographs with nodules. On the left, again, we have a real one with a nodule. And on the right, we have a synthetic one that we generated by inserting an artificially grown nodule into a CT scan. Here we're scrolling through a CT scan. You can clearly observe a difference in radio density between the lungs and the other tissues.
To detect nodules in a given radiograph, a deep convolutional neural network is trained to predict nodule presence. As in the classical example of attempting to classify whether an image contains a cat or a dog, the machine learning model is fed a large data set accompanied with the image labels. Each iteration, the parameters are tuned to optimize the model's predictions on future images. In our case, we want to detect whether or not a certain patch of the radiograph contains a nodule. We use the DenseNet architecture, which has a repeating block substructure and many other advantages over traditional convolutional neural networks. Using full images as input, Raj Prakar et al. Have reported state-of-the-art classification results in 2017, outperforming many radiologists using the publicly available chest X-ray 14 dataset, which consists of over 112,000 images containing up to 14 anomalies visible on a chest radiograph. Despite the promising results shown by previous work done in the field, several factors limit the accuracy of these learned models. First, the chest X-ray 14 dataset provided by NIH was mined using a natural language processing model, which has its own error rate, although the accuracy of labels is estimated at over 90%. Second, the trained classifier accepted an input size of 224 by 224 pixels, a standard in the machine learning community to fit common GPUs, which is much lower resolution than the original 1024 by 1024 pixel images in the dataset. This reduction in dimensionality is accompanied by a significant loss of information, which could be especially relevant in the detection of faint features. Our new approach addresses these issues by generating synthetic data to classify patches, which are chunks of the original image. To synthesize a dataset of X-ray images, CT scans are used as a 3D model of the body. The traversal of X-rays through the body is simulated using Beer's law. To simulate a diseased lung, a nodule is artificially inserted into the CT's voxel array. To select its position, the lung is segmented using a breadth first search algorithm, which simply consists of manually chosen starting points, which then discover adjacent neighbors respecting a lower and upper threshold.
After randomly selecting its position, the nodule is grown with realistic size, radio density, and shape. We randomly generate a shape following this model of nodule growth, which captures its ability to locally migrate. This lobulated model can introduce variation and can be manipulated to fit various nodule properties. And the result is a radiograph with genuine diseased lungs. Finally, image processing is an important step in the creation of both synthetic and real X-rays to facilitate interpretation. Two well-known techniques are employed to automate this step. Gamma correction is first applied to rectify and darken the attenuation distribution, which is originally skewed towards brighter values. Then, contrast-limited adaptive histogram equalization adjusts each pixel value to improve local contrast and edge definition. Here's a chest radiograph before and after gamma correction and histogram equalization.
As previously mentioned, the reduction of image dimension limits the information available to the classifier, which suggests the need for inputting smaller patches. In our method, we employ sliding window detection, a brute force approach for object detection, as it consists of going through each patch window of the image and predicting nodule presence at each one. Starting with a small CT scan library of only 35 volumes, the generation of synthetic dataset patches presents a solution to minimize the correlation between images. For each positive training example containing a nodule within the patch, a negative example of the corresponding region is provided to balance the dataset. With the realistic constraints in nodule growth, the produced patches can be difficult to classify even when told where to focus. However, with minimal hyperparameter tuning, the validation accuracy peaks at around 80%, which provides reasonable results in this exploratory phase.
With the centers of high confidence patches highlighted in red,
We observe the successful detection of the nodule in the synthetic X-ray image, with the exception of a few false positives marked by smaller red dots. In a real X-ray example, the obvious nodule is detected by multiple classification windows. Although there are several false positives, these can be reduced with data augmentation techniques. Several steps can be taken to improve our classification results. In addition to data augmentation, which is the simplest method of introducing variation, there are various modifications to be made to the convolutional neural networks architecture to optimize the learning model for a problem.
I think I stop here. The video.
Network
Yes.
accepts resized patches.
The video is finished. We already managed to classify from
Okay,
this
sir.
video. Let me share again my screen. And discuss on the deep learning future direction. Okay, so current growth of deep learning. Hello, can you hear me?
Yes, sir.
Okay, current growth of deep learning research and industry application demonstrate its ubiquitous presence in every facet of artificial intelligence. It can be a natural language processing or computer vision applications. And with time and research opportunities, unsupervised learning methods may deliver models that will closely mimic human behavior. Just now, I got chance to read at the chatting. There are participants asking me. They're asking me either they are using unsupervised learning. Is it future direction of today in machine learning? Is it on unsupervised learning? So I would like to give the answer yes, because in real world, many things that we cannot predict. We cannot predict precisely what going to be our target look like. So that's why now unsupervised learning is become a very important, and deep learning is one of the methods that we use can reveal all these unsupervised learning solutions. And the apparent conflict between customers' data predictions, laws, and research needs of high volumes of consumer data will continue. Means that today there are many people trying to cheat, and what they tell is not true, but based on their appearance, based on their dressing, based on their attitude, we can predict what kind of person they are, but not from their mouth and so on. Okay, so that's why now become unsupervised. The way they tell is something, but the way they do is something else. Okay, so that's why deep learning technology limitation in being able to reason is a hindrance to automatic decision support tools today. All right, and then the future machine learning and deep learning technologies must demonstrate learning from limited training materials and transfer learning between the context, and also continuous learning and adaptive capabilities to remain useful. Means that we have a data, we have a sequence data in a series. So from that data, actually, we can reveal many information, many important decision making. All right. And that's all for my presentation. And I would like to conclude. Allow me to conclude. Deep learning is mind-blowing now, and it is a new discipline and applied complex neural network architecture and used to model patterns in data more accurately than ever before. And then mathematical modeling brings a lot of benefits and has been widely used in the real world today, such as in the field of deep learning. All right. Okay, with deep learning, computers can now recognize objects in images and videos and transcribe speech to text better than humans can. All right. I think that's all my presentation today. Please allow me to end my presentation here, because I get to know that due to the limited time, and I would like to thank Professor Dr. Hanafi, Chairman of ICAICST, Bapak Agung Budi Prasetyo, co-chair of this conference, committee member of International Conference on Artificial Intelligence and Computer Science Technology, Prof. Ono, President and Management of Institut Teknologi Tangerang Selatan, and all the lecturers, professors, students, conference participants, ladies and gentlemen, to be with me today for the presentation. And I open for the question and answer, and back to you, Miss Yanti Wijaya.
Yeah, thank you, Professor Burhanuddin, for the
most
amazing share of your work. It's always interesting to talk about brain and its always and its neural network, and how to mimic the work of the brain is really something else. And you try to identify the stage and classify the lung cancer using the neural network. It's superb. Yeah. Now let's see what comes into participant minds after enjoying your presentation. So we invite one or two questions for Professor Burhanuddin. Please, Bapak Ibu, if you have questions.
Maybe Miss Wijaya, the first question.
The first question from me.
Yes.
I think it's about a very deep learning. I don't know. Please, we invite all participants to pose a question to this very interesting research.
I have shared another paper with you, on Prakash, Varsha Prakash. You can share with the participant as well.
Sure.
And yeah, in his paper, he already put the area that we can enhance this topic either on breast cancer, ovarian, tumor, or even lung. What of the area that we can see that we can enhance the research for our PhD studies and so on.
And as you said, it's not that difficult to have your research, because 2 or 3 pages is enough, yeah?
Yes. And you can see even in my references over here, you can refer to many toolbox. We have a toolbox, and then you just plug all the data, then you can get the result, and you can classify the image belongs to which group.
Oh, I see.
And easily you can publish the papers in highly reported index journal, ISI or Scopus Index.
Okay, maybe
and
Pak
sometimes
Agung,
for free.
Pak Agung will help us share this document later.
Yeah, sure.
Okay, I think everybody is just amazed by your presentations, and
do they understand?
I'm sure they got amazed with the presentation, but I think if they want to ask you a question, maybe they can, you can share the email or.
Sure. Yeah, sure. You can Google my CV also there. My
I see,
detail.
okay.
You can Google Burhanuddin Man Abu Baida.
Okay, yeah, thank you.
You're most welcome.
Well, since there's no question, I think that's the end of this plenary session. Thank you once again, Professor Burhanuddin, for the sharing of your super work. Please stay safe and healthy so you can keep doing more researches.
Thank you.
Okay, yeah, ladies and gentlemen, that's the end of this plenary session.
And thank you for inviting me.
Yeah.
Thank you, Prof.
It's an honorable moment for us as well. We all got enlightened by what has been delivered by Mr. Ono Wepurbo of ITTS. He's our steering committee member as well, along with Mr. Yan Safarid Huda and Professor Burhan of University Technical Malaysia, Malacca, Malaysia. We would like to express our gratitude for this conference today. Thank you very much to the General Chair of this conference, Dr. Hanafi, the Co-Chair of the ICAICST 2021, Mr. Agung Budi Prasetyo, who has dedicated so much time for this conference, the Secretary of the conference, Mr. Fahmi Rusdi Al-Islami, and the Treasurers, Mr. Yok Kristiono. We also would like to thank Ibu Tuti Lestari, and Mr. Andi Priambodo, and also Mr. Royan Habibi Soekarno for the hard work. Okay, ladies and gentlemen, it's time for 1 hour break. We'll see you again 1 hour after this break to continue to our second parallel session. Thank you very much.
12:20 in Indonesia now? 12:20.
We have, 20.
12:20.
12:20, yeah.
Malaysia 1:22.
Oh, yeah. So I'll see you again in next 1 hour. Thank you.
Thank you. Prof. Burhan, terima kasih.
Ya, sama-sama.
Di progress report.
Insyaallah, insyaallah. Wish you good luck, good luck.
Ya, thank you.
Prof, terbaik.
Ya, terima kasih, Prof.
A very clear presentation.
Thank you, thank you. Okay, see you again. Bye-bye.
See you. Yeah,
Bye-bye,
thank you.
Prof.
Bye.
Thank
Stay
you.
safe. Wish you a nice day.
Yeah,
Okay,
take
Prof.
care.
Ya.
Tadi udah Diana ya, Lid?
Hello. Hello.
Yes, sir. Can I have?
This is Tarak Nath. Ma'am, actually, I was having my presentation from 8:45 to 9, and I mean, since 8 o'clock, I am in this meeting.
Okay.
Are there any other session in 1A? Means what said
So I
the
think
link? I received the link of this.
okay, we'll move your schedule to the end of the last session today. Is that all right?
Okay.
Okay.
Means are there any other link? Means are they parallelly going on? In means what the I received the link of this particular room.
Oh, I see. We're going to have a breakout room after the break. After the break, next 1 hour. So please come back.
I means I heard that. But means may I get the time when I will be rescheduled or somehow like that? Means by what time I will be...
Our second session will be running around 2 hours. Maybe you can come back after 2 hours later.
To this same meeting link or some other meeting link is there?
You may go to this link and then we will put you into another room later. We'll check your schedule later. Okay. Yeah. Thank
Then
you.
how come I will be knowing it?
Sorry.
How I will be knowing it? Means at what schedule I will be there?
Sorry, I cannot hear you clearly.
Means how I will come to know by what time I have to come back.
Okay.
For my presentation.
If you have to move your presentation at the end of the second session, it's gonna be more or less next 3 hours.
Okay, by 3 o'clock.
I will keep you informed.
Okay.
Okay. Thank you.
Ini room B, can I leave it? Saya bisa masuk ke room A enggak? Ini, iya ini room B nih. Room.
It's okay now. Now I have logged in with my phone also. Is this okay now?
Hello.
Hmm? Okay, ladies and gentlemen, time flies, and finally we've come to the end of today's conference. Congratulations and thank you for having presented your paper in this conference. We're looking forward to having you at our next ICAICST. We have the best paper here. The criteria is based on reviewers' review, and the best paper of the International Conference on Artificial Intelligence and Computer Science and Technology goes to condition-based monitoring and anomaly detection of industrial equipment using autoencoder by Mr. Daniel Lagazo from Ateneo de Manila University, Philippines, Mr. Jose Alfredo de Vera III, Ateneo de Manila University, Philippines, Mr. Andre Coronel, Ateneo de Manila University, Philippines, Mr. Joseph Mark Jimenez from Ateneo de Manila University, Philippines, and Mr. Eman Gatmaitan from Ateneo de Manila University, Philippines. Congratulations for Mr. Daniel Lagazo and friends. And once again, on behalf of the organizer of the ICAICST, the chairman of the Institut Teknologi Tangerang Selatan, and the general chair of the conference, Dr. Hanafi, and the co-chair of the ICAICST 2021, Mr. Agung Budi Prasetyo, we would like to address our appreciation to all participants of the conference. We do hope everyone to stay safe, stay healthy, and stay nourished with your future research. Thank you and see you.
Thank you. See you.
Thank you, everyone.
Thank you, everyone.
Yeah, see you at the next conference. Oh, mau foto? Oke. Udah nggak usah nggak apa. Pak Rektor, where are you, Pak Rektor? Okay. Yeah.